More freefall and projectile practice worksheet is intended for you to use as a way to check to see if you're ready for the quiz. If you can do this worksheet, here we go, we have a formula chart. This formula chart, if you can do this worksheet just using the formula chart and a calculator, then you are ready to take the freefall and projectiles quiz. If you struggle, then you need to study some more, review some more, go back to the previous worksheets, and maybe even come to tutorials. Here we have a quick check to see if your answers are correct. Anyone that's not correct, I recommend that you fast forward the video to find that question and see how I worked out the answer. And be sure that when you do this worksheet for yourself, you show your work, because if you don't show your work, you won't get credit for the worksheet. I'll just assume that you copied it from this. Okay. Question number 1. If a rock is dropped from the top of a tall building, how fast will it be going after 2.5 seconds? Well, we have the 2.5 seconds. That's time. Now, key phrase here. Remember, if something says it's dropped, dropped implies two things. One, that the initial vertical velocity is 0. Okay? Also, it implies that it's going to be falling. Gravity is involved, so negative 9.8. Gravity is negative 9.8 meters per second squared. We're going to use the negative 9.8 for not rounding it for the quizzes. Okay, so that is extra information that we can apply to this question. Because it is dropped, we have an initial vertical velocity of 0, and we have a negative 9.8 meters per second squared for gravity. Now, the next thing to do is identify what's the question asking you to solve for. So what am I trying to solve for? That's how fast. So how fast is a question of velocity. Well, if we already have the initial velocity, that's going to be a final velocity. Now, look at all of your formulas. What are you solving for and what do you have? Okay? Almost all of these formulas have velocity in them. Okay? So the most important thing is what you're solving for, final velocity. It must have gravity, initial velocity, and time. Okay? So going through these formulas, this is the formula we're going to want to use. So final velocity equals gravity multiplied by the change in time plus initial velocity. Plug your values in. Negative 9.8 multiplied by 2.5 plus 0 negative 24.5 is what our calculator says. Significant figures, round that to 25. Why is it negative? Because it's going down. Okay? So it's going to be a negative 25, solving for velocity, that's meters per second. That just means that it's going down. That's what the negative stands for. Okay? How far would an arrow fall in 3.8 seconds? So 3.8 seconds, that's a time. All right, how far would an arrow fall? So we can, with that one, assume a simple initial velocity of 0. Okay, 0 is going to be our initial vertical velocity. Okay, well, if it's falling, we have gravity, negative 9.8 meters per second squared. Gravity. And that's all you need. The question is asking for how far, so the question is asking for displacement. Looking at your formulas, which displacement would be appropriate? Well, we have two formulas that solve for displacement here. This one has displacement in it, but gravity is involved, so we're not going to use that formula because we need gravity. Okay, so it has to be one of these two. Now, if you remember the difference between these two, this is the one we use if the initial velocity is not 0. This is the one we use if the initial velocity is 0. Okay? Even if you use this one and the initial velocity is 0, the two formulas would give you the same answer because 0 multiplied by the time would be 0, 0 plus this, which those two are the same formulas there. So in the end, you can always use this formula if you're not sure. But my initial velocity is 0, so I'm going to use this one. I know it's a shortened version. It's faster. So my displacement is 1/2 gravity change in time squared. Okay, so 0.5 multiplied by negative 9.8 multiplied by 3.8 squared. Don't forget the squared. Negative 9.8, 3.8 squared. Get a negative 70.75. So significant figures, we'll go with two significant figures, negative 71. Solving for displacement measured in meters. That's how far an arrow would fall if you dropped it from the top of a building, 71 meters in 3.8 seconds. Number 3, if a ball is thrown straight up into the air with a velocity of 105 meters per second, what will the velocity be after 33.2 seconds? All right, we have 105 meters per second. That's a velocity, okay? Now, if you notice, positive means it's going up, so it's positive, and that's its velocity when it's thrown, so that's going to be our initial velocity. 3.2 seconds, that's going to be time. If it's being thrown up into the air, it's going to be falling. We have gravity, negative 9.8 meters per second squared is our gravity. Okay? The question is asking for final velocity. Velocity after, so final velocity is the question. So final velocity, all right, we could use this one, but we already know what our time is. We want to know what the final velocity is. We have gravity, we have time, initial velocity, boom. That's our formula. Final velocity is equal to gravity multiplied by the change in time plus the initial velocity. So, final velocity equals negative 9.8 multiplied by 3.2 plus 105. So, negative 9.8 multiplied by 3.2 plus 105 gives us 73.6. So round it to 74. 74 velocity units are meters per second. So what does this tell me? Well, this is a positive number. So that tells me at this point it's still going up. Okay? So at this, it still has a positive velocity. So if I throw it at 105 meters per second into the air, at 3.2 seconds, it's still going up before it comes back down. It's still going, so it's still going straight up. It's still going up. It just decreases velocity now to 74 meters per second. Okay? All right. How much time must an object fall to reach a velocity of 85 meters per second? So an object falling, we're going to be able to assume an initial vertical velocity of 0. We have a negative 85 meters per second to reach a velocity, so this is going to be our final velocity. All right, falling, we also have gravity, negative 9.8 meters per second squared. And the question is asking for how much time? So which formula are we going to use? Well, to have to avoid rearranging formulas, we have initial velocity, we have final velocity, and we have gravity. Initial velocity, final velocity, and gravity times what we want. That's the formula we're going to use. Time, final velocity minus initial velocity. Be sure you subtract those before you divide gravity. So here we go. Final velocity, negative 85 minus initial velocity of 0 divided by negative 9.8. Negative 85 minus 0 is negative 85. So negative 85 divided by negative 9.8. Calculator says a positive 8.67, so round it, positive 8.7. 8.7. Solving for time, so seconds are my units. Okay. Question number 5. If a bullet is shot horizontally from a cliff, how far down? If a bullet is shot horizontally from a cliff, how far down will it have gone after 6.5 seconds? 6.5 seconds. That's time. shot horizontally from a cliff. Okay? That's a key little thing right there. So picture cliff, shot horizontally, and it's going to come down. Okay? If it's shot horizontally, then that tells me that the initial velocity vertically is 0. Okay? And it's asking, okay, so initial velocity is 0. Also, because we have gravity, talking about negative 9.8 meters per second squared. That's gravity. All right? Now, how far down will it have gone? So it's asking for vertical displacement. How far down? We're talking about a vertical displacement, so the question is displacement. All right? So gravity, initial velocity, vertically, time, 6.5 seconds. Which form are you going to use? Displacement, gravity, time. Initial velocity is 0, so I can use this version of the formula. Displacement is 1/2 gravity, change in time squared. 0.5 multiplied by negative 9.8 multiplied by 6.5 squared. 0.5 times negative 9.8 times 6.5 squared. Don't forget the squared. And you get a negative 207, da, da, da. So significant figures, negative 210. Negative 210. Displacement measures meters. All that says is that's a 210 meters down from the top of the cliff. All right. How fast will a falling ball be going after 3.8 seconds if it has an initial velocity of negative 35 meters per second? Okay, so it's a falling ball. We have gravity, 9.8 meters per second squared. Okay? 3.8 seconds. That's time. Initial velocity of negative 35. So this ball is being thrown down. Initial velocity. All right? So we can determine that's a vertical initial velocity. Okay? And the question is asking for how fast. So final velocity is the question. So looking at your formulas, final velocity is my question, gravity, time, initial velocity. That's the form I'm going to use. So final velocity is gravity multiplied by time plus the initial velocity. So I get a negative 9.8 multiplied by 3.8 plus a negative 35. Plug it in just as you see it, negative 9.8 multiplied by 3.8 plus negative 35. And you get negative 72.24. So negative 72. Velocity measured meters per second. Negative just means it's going down. Question number 7. How much time does it take the same ball to reach a velocity of 51 meters per second? Wait, what? The same ball. So, the same ball, question number 6. So, we have gravity, 9.8 meters per second squared. It's going to have the same initial velocity, the negative 35 meters per second initial velocity. Okay, it's asking how much time. So that 3.8 seconds doesn't apply, just the initial velocity applies. Okay. So the question is asking for, we have, 51. First, let's do that number. Negative 51 meters per second. That's reaching a velocity, so that's going to be your final velocity. And the question asks for how much time. Okay? So what formula am I going to use? This one solves for time. Final velocity, initial velocity, and gravity. That's what we've got. Perfect. So change in time is equal to the final velocity minus the initial velocity divided by gravity. Plug in the numbers. Final velocity is negative 51 minus initial velocity of a negative 35 divided by gravity, which is a negative 9.8. Okay? So, be careful. Make sure you get that negative in there. Don't forget your negatives. All right? That really does make a difference. So, negative 51 minus negative 35. Okay? If you're going to put the whole thing in the calculator at once, then you need to put in the parentheses. Negative 51 minus negative 35. Close that parentheses for your numerator. Then divide it by negative 9.8. You get 1.6. 1.6 time is measured in seconds. So 1.6 seconds is how much time it takes for a ball with an initial velocity of 35 meters per second down to reach a velocity of 51 meters per second down. Okay? Next one is the marble is dropped. That means we have an initial vertical velocity of 0 from a cliff. It takes 26 seconds. That's time to reach the bottom of the cliff. How high is the cliff? Okay. Gravity is involved, negative 9.8 meters per second squared. That's gravity. Gravity is making it fall. Displacement, initial velocity 0, time 26 seconds, gravity. Displacement is what I want. Here's the formula I'm going to use. So, displacement is equal to 1/2 gravity tangent time squared. So, 0.5 multiplied by negative 9.8 multiplied by 26 squared. All right, for something to fall for 26 seconds is a long time. Don't forget the squared. Don't forget the squared. Negative 3,312. Displacement measured in meters. Significant figures should be negative 3,300 meters. That just means it's going down. Now, how high is the cliff? All right. How high the cliff is, technically we should make that positive because this is measuring down. If I want to measure how high up, then I'm going to be dealing with a positive number. So ideally the number would be that because you're looking up from a different reference point. But I won't take off points for that on the quiz. And that is the worksheet. All the answers worked out.